Right now, like literally as you listen to this, the device you are holding is silently correcting thousands of electrical mistakes a second.
Oh, yeah. Thousands. Easily.
And if it stopped doing that, I mean, if it suddenly refused to flip its own internal compass,
Yeah.
the audio you're hearing right now would just cut out.
Completely.
Your screen would go dark and your connection to the internet would instantly die.
And the wild part is it is entirely invisible to us. Like, we just assume our technology speaks the right language all the time.
Right.
But underneath the glass and the metal, there is this constant, frantic negotiation happening just to keep the energy flowing in the right direction.
Welcome to the deep dive. Today, we have a mission that is, well, it's highly unique. Usually we take a giant stack of articles or, a massive research paper and try to find the narrative.
Yeah, the big picture stuff.
Exactly. But today, we are embarking on an exercise in extreme textual distillation.
I love this.
We are looking at a single, hyper-focused piece of source material. It is a Wikipedia disambiguation page for the term autopolarity, last edited on March 24th, 2022.
Which, I mean, it is a brilliant constraint. For those who might not spend their free time, exploring Wikipedia's backend, that disambiguation page isn't a traditional article.
Right. It's not a wiki page with a huge history section.
No, not at all. It is essentially a crossroads. It's a navigational tool the platform uses when a single term fractures into multiple distinct applications.
That just tells you where to go.
Exactly. It doesn't give you the whole history. It just gives you the absolute purest distillation of what a concept means in different contexts.
And this page is incredibly brief. I mean, it is literally just a handful of sentences.
Barely a paragraph.
Yeah. But the density of what it reveals about how we manage signals, how we measure the world, and how our devices communicate with each other is just profound.
It really is.
We are going to unpack how this one technical concept, autopolarity, splinters across different technological realms. But before we get philosophical, I want to make sure we are actually grounded here.
Sure.
When we say polarity in an electrical sense, what are we actually talking about? Because my brain instantly goes to magnets.
Oh, sure. The North and South poles.
Right. You have a North Pole and a South Pole.
Yeah.
If you try to force two North Poles together, you feel that physical, invisible resistance pushing back at you.
Yeah, that magnet analogy is a great starting point because it really illustrates the concept of strict orientation.
Okay.
But when we transition from magnets to electrical signals, we aren't talking about north and south anymore. We are dealing with positive and negative voltages flowing in a specific direction.
Because electricity needs a path, right?
Exactly. Electricity requires a circuit. If you put a battery into a flashlight backward, like if you reverse the polarity, the energy cannot flow the way the circuit was designed.
So it just doesn't turn on.
Right, the light stays off. But in some devices, reversing the polarity doesn't just mean it fails to work, it can actually destroy the hardware.
Oh, well. It fries it.
Literally fries it, yes.
Okay, let's unpack this. It is a fundamental rule. You either have it oriented correctly or you don't. It is binary.
Completely binary.
Which brings us to our source text. Let's look at the very first definition on this page. We are beginning from the perspective of observation. How do we look at the world?
Okay.
The text explicitly defines our first category, autopolarity digital multimeter, as, and I am quoting here, automatic polarity switching for signals in measurement devices.
Let's isolate that phrase for a second. Automatic polarity switching for signals in measurement devices. What stands out to you when you hear that?
Okay, well, the word that immediately catches my eye is switching.
Switching, right.
Because if I'm trying to wrap my head around this, I think about like an old school paper map and a compass.
Classic analog tools.
Right. If you are lost in the woods, you pull out a compass and the needle points north. But you still have to physically orient yourself. You have to read the map right side up.
Right. The map doesn't do it for you.
Exactly. If you hold the map upside down, the compass doesn't reach out and flip the paper. You bear the cognitive load of doing the mental geometry to match the tool to reality.
And that is the traditional relationship between a human and a measurement tool. The tool provides raw data, and the human provides the context and the correction.
But this text implies something entirely different. If the device performs automatic polarity switching, it sounds like a self-orienting map.
Oh, that's a good way to put it.
Like how a map app on your phone spins when you turn around, it flips itself. So my question is this just a convenience feature? Are we just making the measurement device do the work because we're too lazy to figure out which wire is positive and which is negative?
What's fascinating here is I don't think it is about laziness at all. I really think it is about the purity of the data.
Purity, how so?
Look at the specific context the text gives us. Measurement devices. When you are using a multimeter to measure something, the goal is unadulterated observation.
You just want to see what's there.
Exactly. You want to know the absolute truth of the signal you are probing. If you manually have to dictate the polarity, like you have to tell the machine, assume the signal is coming in from this direction,
Yeah.
you introduce a massive variable.
Human error.
Human error. Exactly.
Well, I see, because if I hook it up backward and the machine doesn't have auto polarity, it might give me a negative reading or it might just throw an error.
Right.
And I might misinterpret what is actually happening in the circuit because of my own mistake.
And precisely. By automating the polarity switching, the device just severs that potential point of failure. It allows the user, you, to focus entirely on the output.
You just look at the screen.
Yeah, you just look at the raw data, the truth of the signal, rather than fumbling with the orientation of the input wires. The device is essentially acting as a buffer.
A buffer between you and the raw electricity.
Exactly. It basically says, I don't care how chaotic the physical connection is, I will internally orient myself to understand it before I show you the number.
That is a wild shift in agency when you really think about it. The tool is no longer just a passive piece of glass or metal.
No, it has agency.
It is actively negotiating with reality before it hands you the result. It is a translator that never asks for your input.
Right.
But wait, if it is switching the signal inside the device, it is still just an isolated event, right?
What do you mean?
Like plug the probes in, it switches the polarity if it needs to, and it gives me a number. It is a static interaction.
Oh, yes. It is entirely static. In the context of a digital multimeter, autopolarity is a momentary action to facilitate a single observation. You are basically taking a photograph of a moment in time.
Okay, so an autopolarity multimeter solves the problem for a single static measurement. But what happens when you aren't just taking a snapshot?
Right. What if you need a video?
Yeah. What happens when you need two machines to talk to each other millions of times a second without human intervention?
And that is where the text takes a very sharp turn. We move from observation to transmission.
Here's where it gets really interesting. The source moves from that digital multimeter definition into two highly related entries.
Okay, let's look at those.
The first is autopolarity differential signals, which the text defines as the automatic polarity switching of differential signals.
Makes sense.
But then the entry right below it is autopolarity Ethernet, defined purely as the automatic polarity of differential pairs in networking. Now, wait a minute. I'm looking at the language here, and there is a massive shift.
It is a subtle shift in the words, but a monumental shift in the architecture.
Right. The general definition just says differential signals. Plural, but general.
Broad.
Yeah, broad.
Yeah.
But the Ethernet definition specifically mentions differential pairs in networking. Pairs.
Yes.
It introduces the concept of two things inherently linked together.
Wow.
And even weirder, it entirely drops the word switching.
That is the crucial detail.
Did the Wikipedia editor just get lazy? I mean, the first two entries explicitly use the phrase automatic polarity switching, but the Ethernet entry just says automatic polarity of differential pairs.
It wasn't laziness.
So are these pairs doing something fundamentally different than a normal signal? Why drop the verb?
If we connect this to the bigger picture, we have to look at what the text is telling us about the environment. The word networking is the absolute key here.
Okay, networking.
In our first example, the multimeter autopolarity was about an observer looking at a subject. It was a one-way street.
The photograph.
Right. But networking is fundamentally different. Networking is continuous, uninterrupted communication. It is a dialogue, not a photograph.
So a pair implies a relationship that has to be maintained over time.
Precisely. While the source text doesn't give us a deep engineering schematic, the language itself, differential pairs, tells us a story.
It's doing heavy lifting.
It really is. It implies two elements working in tandem, defining themselves by the difference between them, rather than just some absolute value. In networking, if those pairs get crossed or misaligned, the dialogue doesn't just get garbled.
It dies completely.
It drops dead. The connection drops.
And that explains the missing word. When the text says automatic polarity of differential pairs and deliberately drops the word switching, it is telling us that in Ethernet, autopolarity isn't an action you take.
No, it's not a verb anymore.
That is a state of being.
You are hitting on the exact philosophical difference. Switching implies a toggle. You flip the switch to take the measurement, and you are done.
Right.
But in networking, you aren't hoggling back and forth for a momentary reading. Maintaining the polarity of those differential pairs has to be an active, ongoing state of dynamic alignment.
Constant vigilance.
Exactly. The system must perpetually handle these pairs to ensure continuous communication.
Visualize the chaos if it couldn't do that. I mean, imagine a global Ethernet network trying to push petabytes of data across the world.
Oh, it would be a nightmare.
If the network couldn't automatically resolve the polarity of its own pairs, if it required a manual switch every time a signal got slightly misaligned.
Which happens constantly, by the way.
Right. The internet would completely collapse in a fraction of a second. Autopolarity goes from being like a polite convenience on a handheld tool to the literal survival mechanism of the modern world.
It is the internal connective tissue.
It's wild.
It is the difference between a tool you hold in your hand and the invisible infrastructure that surrounds you, which actually leads perfectly into the final section of this document.
Yes, the see also section. Because if a concept is this crucial to how technology functions, it doesn't live in isolation.
Never.
To fully grasp a concept's weight on a platform like Wikipedia, you have to look at its neighbors. You have to map its ecosystem.
The see also section is essentially Wikipedia's way of showing you the gravitational pull of an idea. Like, what other concepts orbit around this core topic of polarity?
The text points us to 4 very specific related topics. We have auto-crossover, bridge rectifier, polarity inversion disambiguation, and polarity switch.
It is a fascinatingly diverse list of terms.
So what does this all mean? Because I look at this list, and I am honestly a bit confused by the grouping.
How so?
Well, I see a spectrum of intent, but the scale feels wildly inconsistent. Let's look at the language. Polarity switch and polarity inversion. Those sound like direct, forceful verbs.
Very active.
Yeah. A switch is a definitive, localized action, and inversion is a complete flip, like turning reality upside down. They feel like things you can point to on a circuit board.
Right, a button or a toggle.
But then standing out like a monolith in the middle of this list is bridge rectifier.
It does sound fundamentally different from the others, doesn't it?
It really does. Now, the text doesn't define what a bridge rectifier is. We are strictly bound by the words on the page here.
Right, playing by the rules of the deep dive.
Exactly. But purely based on the etymology, it sounds like heavy infrastructure. A bridge spans a gap. It connects 2 disparate points.
Okay.
And a rectifier corrects something. The root of the word implies making something right, almost like a moral or forceful correction.
Rectifying a wrong.
Yeah. Why is this massive structural thing grouped with a simple polarity switch?
This raises an important question about the spectrum of control we exert over our technology. You are absolutely right to focus on the semantic weight of those terms, and you shouldn't be confused by the grouping.
Why not?
Because the grouping is the point. The source is mapping out the different physical, mechanical, and conceptual ways that polarity is managed across all disciplines.
Yeah.
It is a catalog of interventions.
A catalog of interventions. Okay, I like that. Walk me through that.
Think about the progression of control here. Start at the bottom, a polarity switch.
The manual toggle.
Right. The word switch strongly implies a manual mechanism. It implies a human hand making a binary choice. Click, yes or no, up or down.
So it's the opposite of auto.
It is the absolute opposite of auto. The human bears the entire cognitive and physical load.
Okay, so that is maximum manual control. Where do we go next?
Then you move to polarity inversion. The text explicitly notes that this is also a disambiguation page.
Oh, interesting.
Yeah, that tiny detail tells us that the concept of inverting or completely flipping a signal is just as fractured and pervasive across technology as autopolarity itself. It's a foundational operation.
So it's not just fixing a mistake.
Right. Sometimes you don't just want to align a signal, you actively need to invert it to make the broader system work.
Okay, so we have the manual switch and the purposeful inversion. Where does auto crossover fit?
With auto crossover, the system is taking control back. Crossing over implies navigating pathways.
Like lanes on a highway.
Exactly. It evokes the routing of traffic, much like the Ethernet differential pairs we just discussed. The system is automatically guiding the signal to where it needs to go, crossing lanes if necessary to maintain the flow.
And that leaves the monolith, the
Yeah.
bridge rectifier.
Exactly. Even without an explicit technical definition in the source, your breakdown of the linguistic construction, bridge, and rectifier is spot on.
It sounds so intense.
It is. It speaks to architectural enforcement.
Right.
It isn't just a simple toggle switch, and it isn't just politely routing traffic. It is structurally guaranteeing that the flow is corrected.
Wow.
It is the heavy infrastructure designed to take chaotic, unaligned, bidirectional input and forcefully, relentlessly align it into a usable, unified polarity.
That is so deeply cool. Just from staring at this list of 4 links, we can see the entire philosophical approach to managing signals in our physical reality.
The whole spectrum.
Yeah, you can manually switch it, you can completely invert it, you can let the system gently and automatically cross it over. Or, if the chaos is too great, you can build a massive structural bridge to relentlessly rectify it.
To force it into compliance.
Right. It proves that managing polarity, deciding which way the energy is allowed to flow, isn't just some niche feature. It is a foundational challenge across literally all electronics.
It is the unseen governor of our modern world. Without these interventions, whether manual, automatic, or structural, our technology is just inert metal.
Just expensive paperweights.
Exactly. And, there's one more detail in the source text that I think ties this entire philosophical discussion together perfectly.
Really. I am looking at the text right now.
That is.
We've covered the definitions. We've covered the see also links. What is left?
It is at the very bottom. It is the standard Wikipedia boilerplate text that appears on disambiguation pages.
The fine print.
Yeah. It says, if an internal link incorrectly led you here, you may wish to change the link to point directly to the intended article.
Wait, you were analyzing the automated site message?
Read it again through the lens of everything we just discussed. If an internal link incorrectly led you here, you may wish to change the link.
Oh, wow. I see it.
Right.
The Wikipedia infrastructure itself is managing the routing of information, and it is failing.
Exactly. The system acknowledges that a user might have been incorrectly led down the wrong pathway. The automated routing didn't work.
So what does it do?
It essentially asks the human user to act as a manual polarity switch.
It is asking the user to be the auto crossover to correct the flow of data.
Yes.
The disambiguation page is, in its own way, attempting to rectify the pathway of human knowledge so the user reaches their intended destination.
It's beautiful.
That is incredible. The page about auto-correcting electrical pathways is literally asking the user to help autocorrect the platform's digital pathways. It is correcting polarity all the way down.
It is a brilliant piece of unintended meta-commentary. It highlights the fact that whether you are dealing with a raw electrical signal entering a digital multimeter, a differential pair flying through a global Ethernet cable, or a human user clicking a broken link on the internet,
The challenge is the same.
the core challenge remains exactly the same. How do we ensure the input aligns with the intended output? How do we manage the polarity of the connection?
I think we have successfully extracted every possible ounce of insight from this single page of text.
I think we have.
This has been a wild exercise. We started by tracing autopolarity as a highly specific, helpful feature designed to remove human error for observers using digital multimeters.
Right. The static photograph.
We explored how taking the cognitive load off the human changes our relationship with the tools we use.
And from there, we watched the concept evolve. We saw it transition from a discrete static measurement to an ongoing, vital state of being.
The Ethernet pairs.
Exactly. The continuous management of differential pairs that acts as the lifeblood of Ethernet networking.
We realized that dropping the word switching wasn't a typo, but a revelation about how networks survive. And finally, we mapped its technological neighborhood.
The ecosystem.
We looked at the See Also section and explored the semantic spectrum of control, from the manual intervention of the polarity switch to the heavy corrective architecture of the bridge rectifier.
And this is why spending the time to deeply analyze these concepts matters to you, listening right now.
Yeah, why should they care?
Even if you never pick up a digital multimeter in your life, you are constantly, intimately interacting with these systems.
Every single day.
Your daily digital tools,
Yeah.
your Wi-Fi, the very device you are using to listen to this deep dive, they rely entirely on these invisible processes. They rely on the silent, perpetual management of polarity to keep your data flowing seamlessly.
It really makes you realize how much cognitive and physical labor the machines are quietly handling for us every single second of the day.
It's staggering.
Realizing that there is an entire hidden architecture constantly flipping, crossing over, and rectifying the chaos of the physical world into ordered information. What gives you a profound appreciation for the fragile infrastructure of modern life?
It is a fragile infrastructure. We have built a world that requires absolute alignment to function, and we have outsourced the job of maintaining that alignment to the machines themselves.
Which brings me to a lingering question,
Uh,
something for you to mull over after this deep dive ends.
okay.
We've talked extensively about how all of these systems, from handheld measurement devices to global networking cables, rely so heavily on automatic polarity switching to function properly.
Right.
We rely on the map to flip itself. We rely on the compass to silently align with true north, so we never have to think about it.
We have traded resilience for convenience.
Exactly. So what happens to our interconnected world when these beautifully automated systems encounter a signal or a differential pair that they simply cannot categorize?
When the system gets confused.
Right. What happens when the system encounters an anomaly so strange that the bridge rectifier fails and it cannot correct the flow on its own?
That's a scary thought.
We have long since forgotten how to read the map upside down. We don't know how to manually switch the polarity anymore. When the compass just spins and the automatic correction fails, what do?
We're stuck.
That is a vulnerability hidden deep inside the convenience of autopolarity. Something to think about the next time you plug in a cable, hear that little click, and just expect it to work.